Hello, I'm Zach. I'm a current grad student at Virginia Tech. This is my lightning talk on using interactive maps and generative AI for healthcare equity. So my situation at Virginia Tech is a bit different, where we're working on a National Science Foundation grant. The goal is to partner industry with academia, because most researchers just do their projects and it doesn't necessarily relate, but we directly partnered with the American Dental Association. So instead of the grad students coming up with the research questions, they are coming up with the research questions for us. So what they wanted to know is, where in the United States is there disparities in healthcare in regards to dental accessibility? So to do this, we started using this algorithm called the two-step floating catchment area model. And in very, very basic terms, here on the right, we see an image of different isochrones. All an isochrone is a polygon that represents different driving time. So we see the red represents 15 minutes, blue 30 minutes, 45 minutes, and 60 minutes. So using these isochrones, this method incorporates supply and demand ratios. So to calculate accessibility scores, we're also considering the supply of dentists and the population in that area. So current industries, they might have like an infographic like this that shows small maps and statistics, and others will use just big Excel sheets and lots of tables. So all the data is there, but it's hard to understand. So while this is good, we made them more solid maps of each area. So we did this for the entire United States, but this is just a map of Virginia. Dark blue represents high dental accessibility, and the lighter represents none. Oh, there we go. The general trend amongst all these areas is that urban areas tend to have better accessibility. Okay, so these are the maps we can see in Virginia. Here's the Richmond area and DC area. We kind of see healthcare follow along the highways of the United States. So here's a big interstate that runs along from Washington to Richmond to Norfolk. We see high accessibilities, and this western part of Virginia is more rural, so we see a lot less accessibility. However, the blue stretches follow the Interstate 81, so it follows the highways directly. So we did this for the entire United States, and what the Dental Association wants is, instead of tables and graphs, we make an interactive dashboard. So this is for users and policymakers. So we did this at the block group and county level. If they want to find a location to build an office, they could use this map, seeing where an area might need specific clinics, and also something that's very important is where these offices accept Medicaid and which don't. And we overlay this with all this socioeconomic data, so we can see if there's a correlation between poorer areas, race, and all that. So that's the benefit of this. So as we were developing dashboards like this for them, something that came up was this generative AI chatbot. So this is just a screenshot of just a random bot. But we got thinking, and we're like, this could actually be very powerful if we could incorporate AI into a spatial component. Basically, right now, ChatGPT is great for academics. You can plug in all your files, all is good. But when you put shape files and any other spatial data, it sucks. ChatGPT is not very good with spatial information. It'll hallucinate results, which just means it'll give you an answer that's just completely incorrect. So we wanted to mitigate this problem. So what we did to go around this was basically, if you put in a shape file into ChatGPT, first of all, it's very computationally expensive, and it's incorrect. Not a great combo. So what we did is we provided data on the specific shape files and column names, all from the census data. So here we have this long prompt of instructions, and then we asked it different questions like, how many hospitals are in blank county? And what our model does is, instead of giving us the answer, it generates the Python code to solve that problem. So we asked ChatGPT, this on the left, this long prompt, it generates this code, and then this code is executed on my own computer, and it produces the result. So the answer to how many hospitals are in Fairfax County would be 15. So that's the methodology, and using the Python is very beneficial because it's a lot cheaper, it works, and we're seeing positive improvements with that. So as a case study, we selected 100 random counties, 100 random zip codes, and 100 random addresses in the state of Virginia, and used Virginia hospital data. And we asked these 6 different spatial questions. So we're looking at spatial joins, calculating driving time, and calculating buffer zones. So for the sake of time, these are just some results of like how many clinics are in the area with the zip code 22039. So we used prompt engineering methods, which is just adding more details to the things we asked ChatGPT. And we see initially, out of the 100 questions, it only answered 27 correct for the basic prompts, and then increased slightly as we gave it more information, 35. So when you use ChatGPT, there's two types of methods you can use. You can use prompt engineering or fine-tuning. And basically what fine-tuning is you take all the information you have and condense it into a very specific focus. So we took all this training data that we gathered from the prompts, which is the code that was executed, and all those correct answers, we merged them into our own ChatGPT model, which we call the fine-tune model. So in this case, with the training data for the zip code question, our fine-tune model got 100% accuracy, and it was producing similar code to this. Similarly, this is with addresses and isochrones. So we see the same kind of trend that increases with prompt variation, but then fine-tuning models are looking very promising as it increases with 0 errors and only 7 incorrect. The way it's calculating the isochrones is just using a Mapbox API code to include real-time information, and it is using a ArcGIS geocoder to solve where that address is. So overall, the results from the case study show that the fine-tuned model is very promising, but lots of training data needs to be applied to use it. So this is a screenshot of our actual chatbot that we're developing. And this is different from the results I showed earlier. But you can see this question here. I purposely spelled everything wrong, like how many clinics can I reach in 60 minutes of Accomack. That's a county in Virginia, and Accomack is also spelled wrong. So one of the biggest issues we had developing this was the spelling factor. Because if you're a coder and you know if you spell anything wrong, the code doesn't work. So it was a big issue. But with more training data, the ChatGPT model becomes very, very good at spelling. So looking at this question for the 60-minute driving time, it once again took the Mapbox API, solved, found 60 minutes, and up here, Accomack County, it could recognize the misspelling of Accomack and then correlate it to code to say the correct one, Accomack County. And then we can also do the same with the Roanoke City. So in regards to the dental association, people will be asking these driving time questions. Specifically, they want to find out where the closest clinic is to them. So in addition to these spatial questions, which require code, they're also going to ask just conversational prompts like, why is healthcare important? Our model also can distinguish between Python queries and just when to write a paragraph response. So in this example, we just asked, what is healthcare? My teeth hurt. What should I do? As you can see, it just generates a print statement in Python and executes that paragraph. So this is obviously all in development, but is looking very promising. It has many applications, but mine is specifically to dental healthcare. If you have any questions, here's my email. Feel free to contact, and we would love to collaborate with you. That's a lot. Yeah,
So we have time for a few questions. If anyone has something.
Did you say you did this for the whole U.S.?
The accessibility measurements, yes. We have a block group level dental accessibility map for the entire United States.
That include Alaska?
Yes. Alaska was one of the few states where a few of the isochrones cannot be calculated because it's in the middle of Alaska. But yes, we have Alaska and Hawaii.
Maybe one more? Yeah.
How did you calculate the drive time and distance?
So initially, when we asked ChatGPT, it just created I forget, a 5-mile buffer around it, which is not very accurate. So as we developed this, we incorporated different APIs. So for this one specifically, we're using Mapbox API, and the Python code generates that automatically. Any other questions?
That was awesome.
Cool.
I love that.
Thank you.